Voice test. 1, 2, 3. Voice test. Test. 1, 2, 3. Voice. Okay, class. Assalamualaikum warahmatullahi wabarakatuh. Good morning, class. How are you today? I'm fine. And you? Thank you. Okay, let's start this class with pray together. Rabbi zidni ilma warzuqni fahma. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Qad ja'akum basyairu min rabbikum faman absyara falinafsih wa man 'amiya fa'alaiha wa ma ana 'alaikum bihafidz. Wa kadzalika nusarriful ayati waliyaqulu darasta walinubayyinahu liqaumin ya'lamun. Ittabi' ma uhiya ilaika min rabbik la ilaha illa hu wa'rid 'anil musyrikin. Shadaqallahul 'adzim. Sungguh bukti-bukti yang nyata telah datang dari Tuhanmu. Barang siapa melihat kebenaran itu, maka manfaatnya bagi dirinya sendiri. Dan barang siapa tidak melihat kebenaran itu, maka dialah yang rugi. Dan aku Muhammad bukanlah penjagamu. Dan demikianlah kami menjelaskan berulang-ulang ayat-ayat kami agar orang-orang musyrik mengatakan, engkau telah mempelajari ayat itu dari ahli kitab. Dan agar kami menjelaskan Al-Quran itu kepada orang-orang yang mengetahui. Ikutilah apa yang telah diwahyukan Tuhan kepadamu Muhammad, tidak ada Tuhan selain Dia dan berpalinglah dari orang-orang musyrik. Maha benar Allah dengan segala firman-Nya. Visi, misi, dan moto Stikes Muhammadiyah Bujumbura. Visi, menjadi perguruan tinggi kesehatan yang unggul, profesional, dan islami. Misi, menyelenggarakan pendidikan kesehatan secara profesional. Mengembangkan penelitian kesehatan berbasis ilmu pengetahuan dan teknologi. Melaksanakan pengabdian masyarakat bidang kesehatan. Mengembangkan kehidupan kampus dengan nilai al-Islam ke Muhammadiyah. Moto, unggul, profesional, dan Islam. Okay, class, this is the last class for this semester. So for hospital administration, you have one class with Miss Aprisia, and for the others, maybe you will have next class in next semester. But for this class, I will show you how we improve and how we apply our conversation in English in order to understand about case study about something that related to medical terminology. So I will show you this video. This video is exactly good for you, and just listen and watch the text and try to write on your paper what is the meaning, and in the last you should to tell us in our group WhatsApp with voice note what is the mean, what is that you get it from this video. You should to translate and with your bahasa, and you just tell what is the point of this video. Do you understand? So write on your paper, and you can type later in Korea, and actually you should to share with type and voice note. Okay, do you understand? Okay, I will share this screen, and Okay, here you are.
By brilliance. Whenever I'm teaching the very first lecture in a path, today's video is sponsored by Brilliance. Whenever I'm teaching the very first lecture in a pathology course, I always try and stress to my students one simple perspective. If you could think of anatomy as how to build a body, physiology is how that body works. But pathology, that's how the body falls apart and or is destroyed. And there's a crazy amount of diseases, dysfunctions, and injuries that the human body can go through. Pain is associated with nearly every single one of them. And that's why in today's video, I want to use the cadavers to show you the many structures associated with the transmission and the processing of painful stimuli. It's going to be a fun one. Let's do this. Now, obviously, pain is not something that most of us go out of our way to experience, but I want you to think for a moment, what would life be like if you couldn't feel pain at all? In fact, there are people who suffer from this very problem. They have a rare genetic disorder called a congenital insensitivity to pain, and that's where they can't feel pain in their peripheral nervous system, so like hands and feet, for instance. So just think about this. Imagine not being able to feel yourself burning or getting cut or getting scrapes or maybe even a bone break. You can see already that this is a pretty big problem, and that leads us into what the purposes of pain are in the first place. Pain acts as a warning system. It's alerting you to the fact that something is wrong, or maybe you should stop doing what you're doing because it's only going to get worse. At the same time, pain is also an effective learning tool, right? We've all heard that very cliche story of a child putting their hand on a hot stove, pulling back, and then realizing, hey, I probably shouldn't touch that in the future. Now, obviously, mistakes happen. I burn myself quite frequently when I'm cooking, but it's not as though I'm just resting my hand on the stove. I've learned that lesson. So just think to yourself for a moment, as undesirable as pain may be, it's there for a very specific reason. To fully understand the sensation of pain, we need to first think about other sensations that you experience every single day. These are going to be things like sensing temperature or sensing chemicals or even pressure. So as a quick little experiment, I want you to put your arm out in front of you, and then with your hand, I want you to not touch your skin, but just barely touch the hair on your arms. And as you do that, you are going to be bending the hairs, and that's going to deform the hair follicle that it's growing inside of. And then there's a sensory neuron that is going to send a signal based on that deformation, and you are going to feel light touch. That's what this is called. Now, if I place my hand obviously onto my skin and start pushing into it, I am now triggering a different sensory receptor, and that is what we call pressure. Inside of your muscles, inside of your tendons and ligaments, you have other sensory neurons that are relaying positional information. So watch this. It's kind of interesting. And I'm going to close my eyes. I'm going to put my arm out like this, and I'm just going to start moving around, being all weird and silly, and then whoop, boom, I still hit my palm right dead in the center. I often get worried that I'm not going to pull that off and that's going to be embarrassing, but this is called proprioception, because what's happening is all the neurons inside of my soft tissues are telling my brain, hey, this is how long biceps brachii is, this is how long triceps brachii is. So even without having to see my body, I can still understand where I am inside a three-dimensional space. Now, you also can sense temperature, right? So like think if you're feeling something's warm on your skin, but you feel this within a certain and specific range. In fact, your skin can sense temperature up to around 52 degrees Celsius or 125 degrees Fahrenheit, give or take, but for the sake of argument, let's just say that's the numbers, right? As long as you're experiencing a temperature up to that range, I mean, it might be uncomfortably hot at times, it might be very, very warm at times, but you're not actually experiencing damage to the tissues yet. Once you start going out of that range, and the same will go for the mechanoreceptors, which were the ones that are going to process light touch and pressure and proprioception, they all operate within a specific normal range. And as soon as you go outside of that range, that is when you are going to deal with pain receptors. These are called nociceptors. So as soon as you start to go to, say, 53 degrees Celsius, 54 degrees Celsius, you are now giving the body what's called a noxious stimulus. And that noxious stimulus trips the nociceptor, and it will then send that signal to the spinal cord. So what I want to do is I want to take a look at the cadaver and see these nerves that are going to be transmitting the signal. You are looking at a left arm that's been cut mid-brachium. So this bone right here is the humerus, which makes this muscle the biceps brachii, and then back here is going to be the triceps brachii. But as I rotate it around, you can see the muscles of the forearm. There are 20 of them only in the forearm. And then what you're looking at here are specifically the anterior antebrachial muscles. And there are 8 of them on this side. But we've made some incisions that allows us to look deeper into that forearm. But what I want to focus on, if I slide these muscles back, it's actually going to be this right here. And you can even see an offshoot of it right dangling right there. This is the ulnar nerve, right? So there's going to be an ulnar nerve, there's going to be a median nerve, there's going to be a radial nerve, but we should probably take a moment to discuss what a nerve is in comparison to a neuron. So a neuron is going to be an individual cell. Neurons are going to transmit pulses, right? Action potentials. But when you bundle the neurons together in groups, in large groups, you get what's called a nerve. And the ulnar nerve is a mixed nerve, meaning that it sends sensory information to the brain and motor information out, going to things like the muscles. So let's say you burn your pinky. Well, the ulnar nerve is going to be responsible for the pinky. So as you burn that pinky, that noxious stimulus is going to be transmitted from the ulnar nerve, and it's then going to travel up the entirety of the arm. And from there, it's going to go to the spinal cord. So let's jump over to another cadaver and take a look at the spinal cord. Let's go ahead and take a moment to orient you so you understand exactly what you're looking at. This is the tongue. This is the mandible. And then we have the nose over here. So that makes this the anterior or front side of the head, which then would obviously make this the occipital bone. So this is going to be the back side of the head. You'll also notice that we've made an incision up top. That's why it's so flat, and removed the brain. So we've cut the top of the cranium off and removed the brain, but we will see that brain in a second. This connective tissue here is actually part of the meningeal system, so a really cool piece of tissue there. And then we can see the cervical spine as it transitions into the thoracic spine. But what I really want to focus on is going to be this tissue here. This is the spinal cord, and you can see that it's protected by that vertebral column, that cervical spine. And what you're probably not going to be able to notice is there's also other extensions of the vertebrae back here. So the spinal cord is literally surrounded by bone to protect it. But the spinal cord belongs to what's called the central nervous system. The central nervous system contains the spinal cord, the brain, as well as the retina of the eyes. And this is where processing of information is going to occur. So when we burn our pinky finger, that is then going to travel through the peripheral nervous system in the ulnar nerve, and then it's going to synapse or communicate with another neuron inside of the spinal cord in a location called the substantia gelatinosa. It's wordy, but it's actually going to be pretty important, especially when we talk about how to modulate or limit pain in a moment. But what's then going to happen is that secondary neuron is going to go up the spinal cord and go to the brain, so you can start being aware of the fact that you are getting burned. You are looking at the right hemisphere of the brain from the cadaver that we just were looking at a second ago. But I think it's a good idea to orient you so you understand exactly what you're looking at. What I'm outlining with my probe here, this highly folded region of the brain is called the cerebrum. And these folds are created by these raised areas and then these sunken areas. The raised parts, these are called gyri. So all these that I'm poking with the probe, these are all gyri. And then those dip downs, those sunken areas, these are called sulci or sulci. I like to think of these as mountains and valleys, just kind of helps in my own head. But this creates that folded nature, and that dramatically increases the surface area of the brain. So you can just fit more neurons into a smaller amount of space. But these also create geographical regions. So if you look from here, there is a giant sulcus that travels all the way up. This is called the central sulcus. And it literally divides what we call the frontal lobe from the parietal lobe, right? You're going to have another one right about here. Let's see if I can look in the camera and get this right. So about right here, this is that lateral fissure. This is going to separate the temporal lobe from that frontal lobe. So we have a frontal lobe, temporal lobe, parietal lobe, and then an occipital lobe in the back. Now down here, we have what's called the cerebellum. This is going to be responsible for motor control. And then if I turn it around, we can see a bunch of really exciting anatomy. But I want to focus down here, this thing that, as it comes up, it kind of looks like a seahorse is what a lot of people will say. We are looking at the brainstem as it transitions into the central core of the brain. And this is going to be very important for our discussion. So this first part, this is the medulla oblongata, and then that's going to transition into the pons, and then the pons will transition into this structure here known as the midbrain. Together, these three structures form the brainstem. But then it's going to transition into the thalamus. And the thalamus is going to be very important because what will happen is that secondary neuron that we were talking about that's transmitting the painful signal is going to go up the brainstem and go directly to that thalamus. And you could think of the thalamus as a hub. What I mean by that is it helps to redirect signals to their appropriate location. So it's not the only thing it does. We know of it doing several other things, but that's the one you're going to hear about the most. So what will happen is that painful signal comes up, and it says, okay, we're being burned. I need to alert this area, this area, this area, and it starts sending and distributing out signals to various parts of the brain. And one of the most important areas it does that to is, we flip the brain back over. If you remember me just barely talking about that central sulcus, that line that goes from that temporal lobe all the way up, right behind it, I'm going to kind of trace this region roughly. This is called the primary somatosensory cortex, or just the sensory cortex. This is responsible for sensation. This is where conscious awareness happens about sensation over your body. So very specific parts of it relate to specific parts of your body. So there's a part devoted to your hand, and then a part devoted to your fingers, and a part that's devoted specifically to the pinky finger. So if you get burned on that pinky finger, then a very specific part of that sensory cortex will light up. And it's at this point that you are now consciously aware of the fact that you are getting burned, or you have been burned. Now, some literature does suggest that the thalamus also has some conscious awareness. So maybe it's best to just say the thalamus and that sensory cortex together. This is where you're aware of it. But what's interesting to think about is up to this point, you technically had no idea that you were getting burned. To you, it all happens instantaneously. But honestly, technically, to this point, you had no awareness. The thalamus, though, is also going to send a signal to a structure that unfortunately we can't see. But I'm going to turn the brain here. If we could look where the probe is going in this direction and then about this direction, where those two lines, hopefully you can even see this, kind of put it here, where these two lines would intersect, so about like right there, that is called the amygdala. The amygdala belongs to a separate system called the limbic system. And the limbic system is so cool. We're going to have to do plenty of videos just on the limbic system itself. But the amygdala is responsible for negative emotions. I don't know about you, but if I get burned, I'm not too happy about it. And that is in thanks to the amygdala. And this is on purpose. It goes back to what we discussed at the beginning of the video and the purposes of pain, one of them being to learn. If you are happy about the pain, then you're more likely to do it in the future. And that, for obvious reasons, is a problem because it can cause damage and so on and so forth. So you should respond negatively, and that's from the amygdala. The thing is, pain doesn't just stop here, right? Pain has to be modulated. Because think about it. If I get burned and I pull away, well, my eyes, all of my senses understand that I'm no longer being burned. But there's still an injury. There's still inflammation. There's still all that, just the burned tissue. So what's happening is the nociceptor is still sending the signal. But our brain understands that we're not currently being burned. So what's going to happen is if we go back here, the thalamus is going to send a signal down to this structure right here. And it doesn't really look like much, but I want to explain the surrounding area so you understand exactly what we're looking at. If you notice, there are hollow spaces here. These hollow spaces are called ventricles. And this is specifically a lateral ventricle. There will be a secondary lateral ventricle in the left hemisphere that we just can't see. So you have two lateral ventricles. Then the thalamus, there's actually two distinct lobes to the thalamus. So there's one in each hemisphere. And then there is an empty space between them. So where the probe is right now, that's an actual space. We call that the third ventricle. Then down here, between the cerebellum and the brainstem, there's this triangular structure, this gap. This is the fourth ventricle. Well, what happens is fluid is produced in these spaces called cerebrospinal fluid. That fluid will then travel from the lateral ventricles and third ventricle down to the fourth ventricle, and then that's where it'll escape and then bathe and surround the brain, and so the brain is floating inside of your skull. Well, in order to get from that third ventricle down to the fourth ventricle, there is a tube located right here called the ventricular aqueduct, or the aqueduct of the midbrain. And surrounding it is what we call the periaqueductal gray matter. So if we come up here, you can see that there's a gray portion and a white portion. That gray is a bunch of synapses occurring and cells communicating with each other. And then the white matter is the signals being sent based on that communication. Well, just like you see gray matter here, there is gray matter surrounding the ventricular aqueduct. And so what's happened is the thalamus speaks to the the thalamus speaks to the periaqueductal gray surrounding the ventricular aqueduct, and that's going to cause a cascade of signals to start being sent down the brainstem and going towards the spinal cord. That's a mouthful. There's a lot of terms there. If you're like me, obviously I'm stumbling over my words. Who would have ever thought that neuroscience and neurology would be complicated? But to sum it up and put it like this, when that thalamus says, okay, look, we're not being burned currently, we can start to numb this pain, what it does is it speaks to the periaqueductal gray, which will then speak to several other structures, and it just shoots down the spinal cord and goes to that substantia gelatinosa that we mentioned earlier. That's that location where the nociceptor and the secondary neuron are communicating. It's at that site that the body secretes endogenous opioids. This is so cool. Your body literally creates its own painkiller, and it will secrete it in that space, and that will interfere with those neurons' ability to properly fire. And then you can hear the school bell probably I don't know if any of you can hear that, but that'll interfere with their ability to fire properly, and the end result is you feel less pain. Now, we as humans have figured a way to utilize this by using opiates and then pharmaceutical grade opioids. And we're going to talk about opioids and opiates in a separate video, but it is very fascinating to think that your body does this on its own. But this does lead me to a discussion that I do want to have, and that's going to be based around the subjectivity of pain. Look, I don't want to say that pain is entirely in your head, but pain is entirely in your head. Look, here's a real easy way to think about it. Some of you have probably heard of phantom sensations. So amputees have talked about for years the fact that they will feel sometimes pain or maybe an itch in a limb that has been removed. And this will make perfect sense to you if you think back to that sensory cortex in that parietal lobe of the brain. Because even though the nerves and the neurons and the nociceptors are all gone, the area of the brain that was devoted to them is still there. And so what can happen is those neurons can fire inside of the brain, and that can send strange and sometimes painful sensations to the amputee. So this just really goes to show how subjective pain is. I mean, think about it. If I got two people and I just kicked them in the shins in the exact same location, the exact same intensity, and then asked them on a scale of 1 to 10, how painful was it, they're going to give different responses. And even if they gave the same number, that number doesn't really mean much, because how do you quantify and compare your 8 versus my 8? It just doesn't make sense. So while pain, the structures associated with pain, we know a lot about, right? I can show them to you, and I obviously have. The actual perception of pain is something that we are still learning about. There are different theories surrounding the perception of pain, going back thousands of years, all the way up to just a few years ago, just coming up with new theories, trying to understand how pain is perceived. So while pain is important, while you may not like it, it's definitely important, it's also something that we are still trying to understand. We've been talking a lot about pain, obviously, in today's video, but you know what isn't a pain? Learning STEM subjects from today's sponsor, Brilliant. Brilliant is an interactive online learning platform for STEM subjects. That is math, logic, science, and computer science. Now, I have been teaching science for a while now, and I can't tell you how many times I've heard something along the lines of, science is interesting, but there's just so much to learn. And I actually get that. I really honestly do. That's why I'm always telling my students, once you learn how to think like a scientist, it only gets easier from there. And Brilliant understands this as well. That's why they have several courses on scientific thinking. These courses, which are completely interactive, are designed to challenge and dramatically improve your problem-solving capability and intuition. And trust me on this, there's no better tool to have in your tool belt than high-functioning intuition regardless of the subject matter. If you're interested, go ahead and visit brilliant.org/IHA, or you can just click the link in the description below, and the first 200 people there will get 20% off their annual subscription to pain-free interactive learning. Thanks for watching, everybody, and I will see you in the next video.
Okay, class, that's all about English conversation in medical terminology. Okay, sorry. Especially in one case about what is I mean. It's about physiology of pain. The related of anatomy and physiology in pain case. So I will make so easy for this case. Each one of you just try to understand, try to translate and understand just for about 7 minutes. So I will divide it in three phases. So it's long. That's all of this video is 20 minutes. So the first 2 minute is for nutritionist. So the first 2 minute is for nutritionist major. For student in nutritionist major, you just translate and understand for the first 7 video. I mean, it's about anatomy and physiology of pain. Okay, yes. And the second is for medical record. The second 7 minutes is for medical record student. So you try to understand, translate, and understand about the second 7 minute video. And the last 7 minute video is for hospital administration. So it's one of student in this major should to be done, and try to write and type in, share in WA group, and upload your voice note. This is the first. And next in final exam. So final exam. Yes, final exam. You should to write and share about your video according to this video. Okay, understand? Yes. Yeah. Okay, thank you, and see you in final exam. And for the nutrition and medical record, you will have next class with our team. And for the hospital assistant, I think it's enough that in this year you have 2 class about English 1 and English 2. Okay, Assalamualaikum warahmatullahi wabarakatuh.